Hey YouTube. So I'm back again because I've got another little experiment here sitting on the table that I thought I should do a little video and show you guys what I'm up to. So a while back I had this idea, wouldn't it be nice if there was like a little thermoelectric generator that you could pair with your candle and potentially like charge a phone or like turn on a small light or something like that. And uh, and so I started going online and I started looking for like Peltier devices, and they're expensive. They're expensive and they're not tolerant to the temperatures that a candle flame puts out. So got frustrated with that because I bought a little tag. I actually already burnt one, and uh, and so okay, this is not acceptable. Need a more proper like thermocouple. So I went through and I started looking for dissimilar metals that I have in the house, and I happen to have a special metal called nitinol. It is a nickel titanium alloy that responds to heat. It changes its chemical makeup, and actually they call it a shape memory alloy because you train it to a certain shape and then you can deform it when it's cold, and when you heat it it'll return to its trained shape. Um, Now the other metal that I had, or the other wire I had around the house was nichrome, a nickel chromium alloy. This one is typically used for heating. Um, in fact, you'll often see it called heater wire or resistor wire. Um, the the way that a thermocouple works is you have what's called the Seebeck coefficient. And so what the Seebeck coefficient is it's a measure of voltage produced by a temperature differential across a metal. And so basically pretty much every conductor has well, I mean, not basically every conductor has a Seebeck coefficient, even if it's zero. But some metals will produce a voltage that is coming, it's positive towards the cold side, and then other metals will produce a voltage that's positive towards the hot side. And so the whole idea behind a thermocouple is you take it and you tie them together so that positive goes this way and then positive goes this way. You put a flame on the one spot and hey, you got current. But yeah, so I came up with this little thing here. Now I've got 1, 2, 3, 4, 5, 6 couples. They're all connected in series, and they meet up in the middle over here. And they're held on this ring, and I've got this little voltmeter over here, so you guys can see what's being produced. So right now you can see that the voltage is 0, which makes sense because there's nothing there. There shouldn't be any voltage right now. So we'll heat this up. Now you can see I got a little number forming there. Let's see if I can't. There we go. So we'll start by getting this going. And so you can see as it heats up, it produces more and more voltage. What are we up to now? 43 millivolts. And over 6 couples with a lighter flame. Not bad. And we'll see what kind of current production can come off of that as well. So right now we have, yeah, that's reading in the microamps. And now we'll kick this up. 500 microamps. $600, $500, oh, unless I'm reading that wrong. I'm reading upside down and then I look over that way and I'm reading backwards. Anyway, it's a thermocouple. It's not anything super special, but that's the beginnings of the idea anyway. So if you guys want to see more stuff like this, I mean, this is the kind of stuff I do all the time. Mainly, I'm just trying to come up with little ideas for little devices that I can make and sell. Because right now I'm kind of self-employed and I want to be an inventor. So, anyway, we'll see you, YouTube.